Our design is essentially based upon an aluminium frame with an overlying half on top. To become deployable from a collapsed state to its expandable state, aluminium telescopic poles are used. This grants us the flexibility to adjust the height to suit our own needs. The reason why aluminium was chosen as a preferred material was because of its high strength-to-weight ratio, being economically viable, and the ease of contacting local suppliers.
The shelter design was initially based on an improved reinforced TP, but this proved resource intensive and less viable given the chosen materials. Instead, a shape with similar volumetric characteristics, a hexagonal prism with a trapezoidal profile was chosen. Shelter specifications were changed several times in the development stage. Most notably, shelter dimensions were optimized in order to meet constraints while draining the least amount of materials and resulting in the lowest possible shelter angle. This was in the hope that this would minimize the wind loads experienced during extensive use. To attach the structure's ceiling to its 6 supporting beams, such that it could be simply and readily assembled and packed, several designs were conceived. Eventually, it was decided that by welding small sections of tubing to the shelter's ceiling, inhabitants would be able to assemble the shelter by inverting it, screwing the supporting beams into place, and turning it over once more. This makes the shelter extremely easy to assemble.
We use the hexagon shaft for both top and bottom area. The length of bottom edge is 1.75 meters, which gives a meter square base to achieve 1.8 height to cover the 50% of the ground area. The roof area will be 4 meters square and height of our shelter is 1.8 meter. The telescoping pole is 2 meters long, includes the overlap using for connection. Mass of this shelter is 16.7 kilograms, which includes the pole, aluminium sheet, tabs, and screws. The diameter of aluminium pole was 19.05 and 15.88 millimeter with 1.42 millimeter thick, which is able to stand in 77.16 Pascal wind pressure. The total cost of this shelter will be $80.
Ceiling to its 6 supporting beams such that it would be simple, ready, and easy to erect. The shelter design was initially based on an improved reinforced TP.
That means start.
Yeah, I know, but
I feel like clearing space, like, get out of the way.